Determining the signs of the trigonometric functions of non-quadrantal angles. Going forward, it will be important for you to be able to tell the signs of all of the trig functions given the quadrant of the angle. In quadrant 1, we know that x is positive and y is also positive. So let's write down that. X is positive, y is positive, and remember that r is always considered positive in every quadrant because r is the distance from one point, our origin point, to a point that we pick on the terminal side. So since r is positive and x is positive and y is positive, then keep in mind that all of my trig functions are formed by the ratios of y divided by r and its reciprocal, x divided by r and secant its reciprocal, and tangent, which is y divided by x and its reciprocal. Since all of these would be positive values, a positive divided by a positive is also a positive. And since reciprocals all have the same sign, sine and cosecant would be positive. Cosine and its reciprocal secant will be positive. Tangent and its cotangent, its reciprocal, would be positive. So all trig functions in quadrant 1 would be positive for any angle, of course, that lays where its terminal side lays in quadrant 1. What about quadrant 2? In quadrant 2, x is negative and y's are still positive. So here, x is negative, y is positive, and r, once again, is always positive. So let's look at sine. Sine would be y divided by r. Sine would be a positive value divided by a positive value. So sine is positive and also its reciprocal, cosecant. What about cosine? Cosine is x divided by r. X here is negative, r is positive, so what does that tell me about cosine? Well, negative divided by positive would be negative, and its reciprocal, secant, would have the same sign in this quadrant. So cosine and secant are negative. What about tangent? Well, tangent is y divided by x. Y is positive, x is negative. A positive divided by a negative is a negative. And the same would be true for its reciprocal. So here in this quadrant, we would say that sine, let's write what's positive here, sine and cosecant are positive. If we remember that sine is positive, then we should also remember that cosecant is positive because they are reciprocals. Alright, now let's look in quadrant 3. In quadrant 3, x is negative and y is also negative. So if x is negative and y is negative this time, let's look at all of our trig functions. So sine is y over r. Remember that r is always positive. So y is negative, r is positive. So that tells me that sine will always be negative, because a negative divided by a positive is negative, and so will its reciprocal. So sine and cosecant will both be negative in quadrant 3. X divided by r, x is negative, r is always positive, and negative divided by positive will be negative. So cosine and secant will always be negative in quadrant 3. And let's look finally at tangent. Tangent is y divided by x. Now be careful here, y is negative and x is negative, but a negative divided by a negative gives me a positive value. So tangent and cotangent will both be positive in quadrant 3. If we remember that tangent is positive in quadrant 3, then its reciprocal, cotangent, will also be positive. Lastly, in quadrant 4, x is positive, but y will now be negative. So let's look at our trig functions. Y divided by r. Y is negative. R is always positive, so sine will be positive as well as cosecant. Negative. A negative divided by a positive will be negative. Cosine theta, secant theta. Well, cosine is x over r. X this time is positive. R is positive. A positive divided by a positive is positive. So cosine will be positive as well as secant. And lastly, tangent. Tangent is y divided by x. Y is negative, x is positive. A negative divided by a positive will also be negative. So tangent will be negative and cotangent will be negative in quadrant 4. So in quadrant 4, cosine and secant are positive. If we remember that cosine is positive in quadrant 4, then we should remember that its reciprocal, secant, would also have the same sign in that quadrant. Now there are ways to remember this. Sometimes people remember it as all from quadrant 1. All students, so all are positive in quadrant 1. All students, that S would stand for sine, take, the T stands for T in tangent, calculus. So all students take calculus. All means that they're all positive in quadrant 1, and then in quadrant 2, students means sine is positive in quadrant 2. Take means in quadrant 3, tangent would be positive, and calculus stands for cosine. So all students take calculus. That will help you remember which functions are positive in each of the 4 quadrants. Now that we know which trig functions are positive in which quadrants, let's start to work with that idea here in example 2. In example 2, we are asked to identify which quadrant that the angle lays in given the following conditions. Part A, cosine theta less than 0 and sine theta is also less than 0. When we are told that a trig function value is less than 0, then that tells us that that trig function value is considered to be negative. So we are working in a quadrant where cosine is negative and also sine is negative. Well, cosine is positive, we know, in quadrant 4 and also positive in quadrant 1. So for cosine to be negative, we either working in quadrant 2 or we are working in quadrant 3. So these are where cosine is negative. In sine theta, for sine theta to be less than 0, for it to be negative, we are sure that quadrant 1 sine is positive, and in quadrant 2 sine is also positive. So sine is only negative in quadrants 3 and quadrant 4. So which one quadrant are we talking about if both cosine and sine are both negative? That must be describing quadrant 3. So for sine and cosine to both be negative, we must be living in quadrant 3. So the angle theta lives in quadrant 3. In part B, cosine theta is greater than 0, which means that it's positive. Secant theta is also positive, greater than 0. Now cosine and secant are reciprocals of each other. We know that they are both positive in quadrant 1. They have the same signs. in whatever quadrant they live in. They're both positive in quadrant 1, and they are also both positive in quadrant 4. So we could be talking about actually two particular quadrants. So we have more than one quadrant which we could be describing. We could be describing quadrant 1 and quadrant 4. So both of those would be would satisfy the conditions for where theta could lie if cosine is positive and also secant is positive. In part C, cotangent theta is less than 0, so we want to find where cotangent is negative, and secant theta is less than 0, so we're talking about where secant is also negative. So where's cotangent negative? We know that cotangent is positive in quadrant 1 and in quadrant 3. So for cotangent to be negative, we're talking about quadrant 2 or quadrant 4. Secant is negative. Let's first describe where do we know that it's positive. Well, we know that secant is positive in quadrant 1, and we know that secant is positive in quadrant 4. So for secant to be negative, we are describing either quadrant 2 or quadrant 3. So which quadrant are we talking about if we must have cotangent being negative and secant being negative at the same time? Well, they would both be negative at the same time in quadrant 2. So in quadrant 2, both of these functions would be negative. Now this time in example 3, I am going to give you the angle that we were talking about, our angle theta, and everything else we've just said theta. We didn't describe what the actual angle was. In these examples, in part 3 here, example 3, I'm going to give you the exact angle, and I'm going to ask you to come up with the signs of all of the trig functions for that given angle. So if angle theta is negative 115 degrees, we first want to know what quadrant our angle lays in. So we want to put our angle in standard position, negative 115 degrees. Well, if I go 90 degrees in the negative direction, that puts me here, and we need to go a little bit more, and that actually puts me into quadrant 3. If I go all the way past into quadrant 2, then of course we will have gone negative 180 degrees plus a little bit more. So we are clearly laying in quadrant 3. Now remember that it's all students take calculus. So in quadrant 3, tangent is positive. So we have positive values for tangent and its reciprocal cotangent. Everything else in quadrant 3 would have a negative value. For 855 degrees, we want to know first, what quadrant does the angle lay in? Let's use our shortcut. We talked about 855 degrees. Let's divide that by 360 degrees. That way we will know how many complete rotations that we have. So 855 degrees divided by 360, that gives me 2.375. So I have two complete rotations. So 855 degrees minus two complete rotations, 360 degrees. That would be 855 minus 720. And that gives me 135 degrees. So we know that 855 degrees is coterminal to 135 degrees. It's a positive angle in standard position. So we know we want to go one complete rotation, two complete rotation, and then we want to go 135 degrees more past those two complete rotations. that puts me into quadrant 2. All students take calculus. So that tells me that in quadrant 2, sine is positive along with its reciprocal. So sine is positive and its reciprocal cosecant is also positive. All of the other trig functions will be negative in quadrant 2.